Bismillahirrahmanirrahim. As you know that in previous lecture we have discussed the wave speed and derived a formula for the speed of the wave. That was an equation which is known as universal wave equation. Now today we are going to solve example 10.6 and assignment 10.6 on the topic that was wave speed. So here in example 10.6 we are given that a student vibrates the end of a spring at 2.6 Hertz frequency. This produces a wave with a wavelength of 0.37 meter and calculate the speed of the wave. Here we are given the frequency of the vibration and wavelength of the wave, and we have to calculate the wave speed. So I will write given data is, in given data we are given the frequency. So frequency, I will write frequency. Symbol wise it is denoted by small f. So frequency is equal to 2.6 Hertz, and the next data which is given in this example is wavelength of the wave. Wavelength is denoted by Greek letter lambda, and its value is 0.37 meter. Now required data which we have to calculate is speed of the wave. Speed of the wave is represented by v, as it has to be calculated, so I will put a sign of interrogation here. Now solution, I will give solution heading. After that I will use the universal wave equation by using universal wave equation, which is v is equal to f lambda. Here both frequency and wavelength are in product, so this is just direct formula. We have to calculate speed, so I will just put the values for frequency and wavelength. So I will write that putting the values for frequency for f and lambda, which are given as v is equal to f is equal to 2.6 multiply wavelength. Wavelength has the value of 0.37. So multiplying these values we will get the answer as 0.962. As it is the wave speed, so I will put the unit for speed as meter per second. So this is our required solution for example 10.6. Now in assignment 10.6 we are given that a sound wave of wavelength 1.7 multiply 10 power minus 2 meter. Calculate the frequency of sound if its velocity is 343.4 meter per second. Here I will write the given data is wavelength. Wavelength is denoted by lambda, so its value is 1.7 multiply 10 power minus 2 meter, and velocity or speed of the wave, which is represented by v. So v is equal to 343.4 meter per second. In required data I will write the frequency of the wave, sound wave. Velocity is this one and its wavelength is this one. I have to calculate the frequency. Required data. Frequency is denoted by f. So solution using universal wave equation, which is v is equal to f lambda. I have to modify this equation for frequency, so I will have to eliminate lambda from here. So dividing both sides by lambda, So it will become as V divided by lambda is equal to F lambda divided by lambda. They will cancel with each other. So write this equation from this side. So V by lambda. Now putting the values. F is equal to, value for V is 343.4 divided by value for wavelength is 1.7 multiply 10 power minus 2. So frequency will be equal to, dividing 343.4 divided by 1.7 and shifting the 10 power minus 2 into numerator. So its value will become 10 power 2, its exponent will change to as positive. So dividing these values, we will get the answer as 202 multiply 10 power 2. Now I will write this answer in scientific form. So the decimal point is here, I will have to shift it between 2 and 0. So the answer will become 2.02 multiply 10 power, as I have displaced it 2 decimal points, so there will be a 2, and multiply 10 power 2. As bases are the same, so I will add their exponents. So 2.02 multiply 10 power 2 plus 2. So its answer will become 2.02 multiply 10 power 4, and the unit for frequency is hertz, and this is our required answer for calculating the frequency for this assignment. That's enough for today. Thanks.